is John, and I'm at BU. I'm going to talk about cross-forecast synthesis in Cyberinfrastructure and near-term ecological forecasts. I'm part of the near-term ecological forecasting initiative team at BU. And so, just a little rundown, I'm going to give you an update on where our net new forecasts are at currently. We do have an algal bloom Leon team. I'm not going to talk about them because they were posted today, and they're doing some really awesome stuff, so make sure you go check it out. And then after running through that, I'm going to just give you an overview of our Cyberinfrastructure that we've been thinking about and trying to develop. Okay, so for our carbon flux forecasts run by Mike and our tech, Katie Zarada, they're forecasting net ecosystem exchange and latent energy out of Willow Creek, Wisconsin. All of these are 16-day forecasts that are made every day. These are up on a Shiny dashboard. Next is our phenology group run by Mike and grad student Catherine Wheeler, and they are basically forecasting percent canopy cover at 10 deciduous broadleaf sites on the eastern seaboard, and they're assimilating PhenoCam data, which is in red here, basically in real time, which is super cool. Next up is our soil microbe group run by Jennifer Batnagar, Colin Averill, and Zoe Werben, and they're actually making forecasts in space, and these are spatial forecasts to neon sites, which is what they're using for their out-of-sample validation. And they found that predictability increases at scale, so soil cores are nested in plots, and plots are nested within sites. We're better at sites than cores, and we're also at better at predicting higher-level taxonomic groups. So at the bottom, looking at just one specific phylum instead of the entire microbe community at large. And then last but not least is what I worked on, which is tick forecasting on the Carey Institute of Ecosystem Studies with Shannon Du. Here we're looking at the historical time series fit and then a hindcast past 2005 with uncertainty for repetition for both of those. And next up for our project is to integrate some community data to help narrow down our predictions as well as get a better understanding of the phenology that we should expect from each life stage. Okay, so now that we are updated on what we're doing, let's talk about computing and ecology and Cyberinfrastructure. So we can think of computing on the spectrum, right? So on the one side, we have just working on our laptops, running a script. And on the other side, we have dedicated resources and Cyberinfrastructure to solve some sort of problem. And we can think of that as maybe what the National Weather Service uses to make radar images for the contiguous United States in near real time. I think we can all agree that we don't need this here, but sometimes running a script locally isn't enough. I don't know how many of you are like me and crash your computer running R, but sometimes that's not enough. So in ecology, we sit somewhere in the middle of this spectrum. And so when we sit here, we have some things that we need to think about. How do we scale up? How do we make our system reusable, and how do we make it accessible to the community at large, and how do we make the community contribute to what we're doing? So at NEFI, this is sort of the system that we have set up and what we're thinking about doing. I just want to emphasize this is very in progress, very beta, as they say. But basically, it works by the user or the forecaster works on a web interface to make their forecasts. It goes into this orchestrator and scheduler, and what that does is it builds a container around each forecast and sends it to the cloud. Forecasts are run, and forecasts come back to the user. We're using two cloud-based services, and Ken kind of touched on this earlier, but the Genie nodes are moving compute to data, which is something that we've really thought about, especially when we have sites that are using neon sites that are across the country. We can really take advantage of that resource. So this is kind of what the infrastructure looks like, at least when you first log in. Any forecaster can create an account, and then all it is just dragging and dropping your barcode into this green box here. And what we do have set up and working is the automation part of it. So you can set up, if you so choose, to run your forecast every however many hours or every many days, or none at all. And you can load any libraries you want, and if you don't need to check that out on the internet, you just have it locally, you can just upload a zip file and run everything there. And then what comes back is on your user dashboard, all your forecasts come back, you can view your results, you can compare your models, Everything, all the metadata and data that comes back is in a JSON, which you can download, and you can just do quick and dirty plots in the interface as well. And so with that, next team on the left, our computer science colleagues are on the right, who have really helped with building the actual infrastructure we have right now, and funded by the NSF and the Rocket Institute at the U. Thanks.